On the Curiosity. NASA's most advanced and expensive rover will soon finish its 9 months, 569 million kilometer journey to Mars. Scientists are describing its descent to the Martian surface as 7 minutes of terror, as Curiosity attempts an unprecedented landing procedure completely automatically and with long periods of communication blackout. Hopes are high for success despite the huge risks.
7 minutes of terror and zero margin for error. Curiosity will take 7 minutes to plunge through the Martian atmosphere before touching down. In the most complex landing sequence for a Mars touchdown ever, it will be lowered to the surface by a sky crane. Inside those few minutes, the rover will slow from over 20,000 kilometers per hour to a complete stop. Every intricate step must happen in the right order, including the firing of 76 small boosters. One small error could mean complete failure. NASA has around $2.5 billion riding on the mission, but Curiosity is the smartest and biggest interplanetary rover ever built. It weighs almost a ton and is the size of a Mini Cooper. Powered by nuclear fuel, it carries more sophisticated detection equipment than ever before. This journey, which began in November, is part of a sustained, coordinated program of Mars exploration. NASA says the mission will focus heavily on the search for water and extraterrestrial life, past or present. If all goes to plan, Curiosity will land about 4.5 miles south of the planet's equator, in the center of the ancient Gale Crater. A video camera aboard will capture the dramatic final minutes of the descent. But it will be another 14 minutes before Earth scientists know whether Curiosity has survived the landing, due to the time it takes radio signals to travel between Mars and Earth. Vanessa Duffy, CCTV.
Being by far the most sophisticated Mars prober to date, Curiosity is looking to break new grounds in many aspects. Wu Haojun tells us more on this.
First breakthrough, the landing. According to NASA, the toughest part of the mission starts when the rover makes contact with the atmosphere of Mars. The whole landing process is estimated to take 7 minutes. During that short amount of time, Curiosity will travel 128 kilometers through the Martian atmosphere, under high temperatures of up to 2,400 degrees Celsius. So far, of all 11 missions in which successful contact was made with the Martian atmosphere, 5 failed during this phase. Second breakthrough, the equipment. After the 7 minutes of terror, the Curiosity rover will land on the Gale Crater. During its exploration efforts, Curiosity is to face the perils of extremely low temperatures, heavy wind, sand pits, and cliffs. In order to overcome these adverse environmental conditions, Curiosity rover has been engineered in a completely new way. Its size is twice that of its predecessor, Spirit and Opportunity, and its weight 5 times. It also carries state-of-the-art scientific instruments set to have a combined weight 15 times of its predecessors. Third breakthrough, the deepest exploration. Scientists believe that organic molecules in Mars can be hidden as deep as 1.5 meters below ground. Past Mars probers can only collect loose surface soil, where because of exposure to cosmic rays, the detection of organic molecules is unlikely. Equipped with a 1.8 meter long mechanical arm with 5 joints, Curiosity can drill up to 10 centimeters below the surface of Mars. Fourth breakthrough, being the longest serving. According to NASA, Curiosity is expected to serve on Mars for 2 years. In fact, its predecessors Spirit and Opportunity have both served longer than scientists' estimation. And Curiosity should be no exception. Carrying a nuclear reactor weighing about 45 kilograms, Curiosity can generate 2.7 kilowatt hours of electricity per day, and that is expected to be able to sustain its mission on Mars for at least 5 years. Fifth breakthrough, the ultimate mission. A recent study showed that traces of complex organic molecules exist under the Martian surface, especially in relatively new impact craters. Some scientists believe that life may have started on Mars and was brought to Earth by asteroids or meteorites. One key purpose of Curiosity's mission is to survey the surface of Mars to find out if it's conducive to microbial